Welcome to Doll Dignity of Labor KTC series, Know the Course. Today we have Santosh with us, who is a IC graduate, Instrumentation and Control Engineer. Hi, Santosh.
Hello, how are you
Hi,
doing?
how are you? I'm doing great. Thanks for asking, and thanks a lot for accepting our request. So, just to quickly start off, can you give a brief introduction of yours and also what is Instrumentation and Control Engineer for the viewers?
Okay, so good day everyone to whomever is seeing this particular podcast. This is Santosh. I am an I'm an graduate from NIT Trichy pursuing Instrumentation Control, batch of 2022. So currently I'm working in ExxonMobil as an instrumentation and control engineer. It's been almost 2 years into the company. To all those who don't know what is an instrumentation control, let me tell a fun story that one of my one of my roommates in college, he actually thought that instrumentation and controls has to do something with musical instruments. To be very frank, I think most of us would don't know in detail what instrumentation and control is, but trust me, that is one of the most fascinating field that I could have probably witnessed because by default, like during my childhood or even after school, I was mostly pursuing into chemical engineering. But this instrumentation and control engineering is something which seems as a very small thing in the whole industry aspect. But when you look dig deeper, it's actually that without instrumentation and control, you wouldn't have any industries running with precise and accuracy and all of that. So, in a nutshell, what instrumentation and control would be is that for say an example, you have a water tank at your home. You would want to probably measure the level of that particular tank. And say, for instance, if your motor, you have switched on your motor from your sump and the water is filling, we would have probably witnessed situations where the tank gets overfilled and the water leaks out. So this is exactly an example where instrumentation and control comes into picture, wherein we would have level instruments to measure the level, and once it reaches the top of that tank, the particular water, we would control in such a way that we would have algorithms in such a way that we would control the flow of water from the sump and stop when it reaches the brim of the tank. So this is in a nutshell what instrumentation and control I would say. But yeah, let's dig into deeper as we go
Yep.
through the part.
Yep. Nice. That's a very good real life example, I would say, which is a day in, day out thing that we happen to use in all our homes. And either we are in
Exactly.
hostels or in any PG or anywhere. That's nice. So apart from this real life example, if we have to detail out like the sectors or the real life applications of instrumentation control engineering, what would be those, Santosh?
So when you look into instrumentation and control in deep, there are two aspects. One is instrumentation as a whole, and then the control system and associated subjects. So I would say there's no any specific field. It would be when you study instrumentation control. Say, for instance, in computer science engineering, it is more towards that you either work in the front end or in the back end. But at least, for example, of instrumentation, there is no specific field that you have to pursue. Rather, it is just broad open that you can work in a process industry, like a petrochemical industry, or you can also work in a completely different sector like home automation or a different sector. So I would say. So at least when we look into a deeper instinct, one is that instrumentation as a whole, when you look into basics, would be all the sensors, what are the associated sensors, what are the associated transmitters, what are the associated instrumentation is occurring. But the application of that is not just restricted to process industries, as most of the people have this perception. It is also broadly classified into various other sectors as well. Say, for instance, when you go to airways is something where we don't actually find people wouldn't think that okay, there is something of aerospace engineering or aeronautical engineering, nothing, that's all. But the amount of controls involved and instrumentation involved in an aircraft is so humongous that we would probably not look into that deeper, I would say. So
Correct.
this is a field whenever people approach me and ask about what is the future scope of instrumentation and control, I would say that it's not just restricted to process industries because process industries do have a major application of instrumentation and control, I would say, but that's not just it. There are few more things coming up in the future. One other example would be micro electromechanical systems, MEMS devices, which I guess probably that is one of the coursework which people would come across in the instrumentation and control course. So that is a huge field where it is growing currently. Imagine all of the sensors and all of the electronics being narrowed down into one single chip. and that helps in reducing the cost, the amount of production, the amount
Yeah.
required for production, and the space constraint. That is something which is very really, what is it, mind blowing thing
Yeah.
currently.
Correct.
So I think I answered the question wherein it's not just one single field, there are multiple fields in which we can explore and dive deep
Yeah.
into.
That's nice. So, and going back to your previous answer, like when you had an intention towards chemical engineering, but you found your passion
Mm.
or interest towards ICE. So, what are the prerequisites that one should have or good to have skills that, before I join ICE, or should I select or eliminate an option of choosing instrumentation and control engineer as my undergrad course? How do you do that?
Um, I would say that like all of the prerequisite assets, like in any engineering subject, when you take,
Hmm.
say for instance, it's a chemical engineering, we would
Hmm.
definitely not know the depth or intricacies of each and everything in detail.
Correct.
So, but I would say it's a general engineering course. Whatever we have in our physics, chemistry, and maths, that is very basic, fundamental, I would say, because one should not probably dig deep into what is pressure, what is
Hmm.
temperature once coming
Hmm.
to the college. Those are things which we would probably learn in depth and detail during our school, college, during our inter school and high
Yeah.
schools. So in
Yeah.
that case, I would say let's just focus on whatever are there in our engineering syllabus for 11th and 12th, like the physics, chemistry, maths. And obviously,
Hmm.
I would say a little bit of computer science knowledge would also help because we are a field wherein we stand in between the circuital and non-circuital. Non-circuital meaning
Hmm.
the computer science aspects as well.
Yeah.
So there are certain aspects wherein we would want to probably program a microcontroller, say an Arduino code, to run
Hmm.
to run a basic simple example. So that would be really helpful if we know the basics of the computer science aspect as well. Just I
Hmm.
mean, not in the basic session there are multiple languages. So
Correct.
at
Yeah.
least for us we learned C++, but when we came to college it was Python. So the interface might be
Hmm.
different, but the
Yeah.
definition of each and everything, say for example, what is a class, what is an object, all of that would remain same irrespective of the languages. So I
Yeah.
think a very basic knowledge on that and an in-depth knowledge of physics, chemistry, and mathematics would help. But other than that, I would say like probably first year of your course would probably deal with not into too much of instrumentation, the basics of physics,
Yeah. That
chemistry,
is, yeah.
maths. So I think that even if things are missed out in school, they would probably be covered. But it's an added advantage if you have the skills prior to it.
Yeah, that's nice. So, like during your 4 years of course, during undergrad, you will have around, quite a lot of subjects. But if you have to categorize, like, what are the prime buckets that you will study? And in each of these buckets, how much is a lab-oriented and the theoretical-oriented courses within that? So, what proportion that goes into your, yeah.
Uh, so I would say at least if I say if you ask me to pick up say top 3 or 4 courses of instrumentation control, I would say that the one would be definitely the sensors and transducers and industrial instrumentation. So these
Hmm.
two courses in terms of instrumentation, it covers a huge chunk of concepts involved in it. Sensors and transducers talk about what are the different types of sensors, what is the technology behind it, and all of that. Whereas industrial instrumentation covers a in-depth detail about transducers, transmitters, what are the different types of parameters, pressure, flow, temperature, level, how do you measure that, what are the different criteria we need to consider, because these instruments or these sensors would be common for industries irrespective of whether it is process industry or a home automation system or a rubber industry, anything of that sort.
Hmm.
But these concepts will be required, or the understanding of which is uh, quintessential for people like an instrumentation and control engineer. These two courses I would definitely say are a prerequisite. Coming to the control system part, I would say the control system 1, control system 2, and process control. I'll let in what is control system 1 and 2 here. So control system 1 would be probably the basic control, like not the advanced state space control
Hmm.
algorithms. It will be
Hmm.
basic controller, control logic, how a feedback control works, what are the different kind of models like state one, state two models, wherein we have the different kind of overdamped, underdamped, critically damped, all of those systems. So it'll help us and understand how a system as a whole works. So it is not
Hmm.
just that we are working only on control system as in, okay, this is a controller, what does it do? Not just that, it just helps us in understanding the process dynamics more better and how do we alter our process dynamics in order to control the process. So that is the most important criteria, I would say, for control system one. Control system two would deal in deep into state space model and multivariable. So whatever we do in control system one will be single input, single output systems.
Hmm.
But in case of my control system two, it will be multiple input and multiple output. Say for example, if you have a robot which would have to control or a self-balancing bot, you can say, for which the
Yeah.
primary function of which is to control the motion of itself. So for which it would have multiple parameters as inputs to it, not just the motion. It would
Yeah.
have the vibration associated to it. So those kind of systems, we can't use the conventional controls which is in place. So in that case, we would go into multi output system, state space model of systems, and there would be different control algorithms to control it.
Yeah.
So that will be under control system too. And one of the major piece or chunk which most people would probably not look well into detail is the process control. And also there a little bit towards that would be the DCS and PLC communication. So
Mhm.
these two chunks, process control and DCS, are probably the vital ones which would require for our understanding. Because we would understand, okay, controller controls it, but how does it control it? Okay, it's through a control valve. What is a control valve? What do we exactly do in it? What are the parts in it? What triggers my transmitter from the controller
Mhm.
to the control valve? What is the signal? What are the different types of conversions we have? All of that will be dig deep into detail in case of process control, and they will also talk about what are the different types of algorithms to control. What is a ratio control? What is a PID control? What are the different types of control algorithms which have Ziegler-Nicholas control tuning methods? All of that would be dwelled into detail in case of my process control. And obviously, the DCS and PLC, that is the face and of all the industries, irrespective of what the industry is. So whatever systems, whatever sensors we have mounting in the field, it will directly go to my DCS or PLC. So that is something which these are the subjects which I would ask any one of us
Yeah.
to focus. And obviously, there are other niche courses wherein we can develop our personal interest. Say, for instance, there is an elective course called Instrumentation Control in Power Plants. So if at all
Mhm.
someone is working in a power plant or is interested on how things work in a power plant, so that is a
Then
very niche course wherein he or she can cover it up. So, or there is another course called Principle of Communication Systems. That's a completely different scenario, not just into instrumentation control. How is this applicable in communication systems as well?
the-
So those are the things which would help us in enhancing our learning.
yeah.
I hope I answered your question.
Yeah, yeah, yeah. So, are there any hacks that you when you have multiple subjects, okay, like across 4 years, if you want to maintain a decent CGPA, do you follow any hacks? Like, do you have a pre-read sessions before your semester starts, or how do you do that?
I wouldn't say pretty much I did not have any hack
Mhm.
system as such, but definitely one thing is that to maintain a good CGPA or to have passion towards the subject, all it takes is to learn it with passion. I think most
Mhm.
of the people who join instrumentation control don't know what is instrumentation control in the first place.
Mhm.
They could be graduates who are interested in computer science but did not get computer science, ended up in
Yeah,
instrumentation. But I just want to emphasize the point that instrumentation and control is also a subject where it has its own merits
correct.
and advantages, which would help in choosing a career path. I think that passion and that zeal, once you start learning into the subject, you will get the understanding and the interest. Once you develop that, it will be easy for you to have a learning. To be very honest, when I joined instrumentation control, I wasn't aware of this much in detail. But as and when I study, as and when I listen to lectures, that is something which helped me captivated the interest, develop the interest. And trust me, once you develop the interest, it will be very easy to learn and very easy to have a track. You need not go and learn on the last day of exam in order to crack it out. It will
Yeah.
be very much helpful. And trust me, all the lab sessions which would be there, at least for the subject which I covered earlier, all of them would have a specific lab session associated with it. Even industrial instrumentation, process control, control systems, all of them would have it. So you will be in a position to learn even hands-on experiences that would probably help you to understand even more better and have the satisfaction that, okay, yeah, this is what I learned in the theory and applying in the practical life. So that
Agreed.
would help in gaining confidence to learn rather than if you have a mindset of just cracking it out just for the marks in CGPA, that wouldn't work because instrumentation and control is not that kind of a subject wherein it will require mugging up and just delivering the answers whatever we expect. If you have the right passion and the right zeal towards the subject, I'm sure that even if many hurdles come, you would be able to answer it in a position. Yeah.
So, is there any popular toughest subject in ICE?
I would say the control system aspects, I would say, because that has
Mhm.
been a real difficult
Right.
subject, I would say.
Okay. Yeah.
Like again, control system, I wouldn't say the control system one, two, but there are certain courses where we would deal into depth, like optical and robust
Mhm.
controls. Those are courses which probably would come in honors, but still. those courses or a little bit detail into control system too would be a little bit difficult and challenging. It's just that it involves a lot of mathematics in it, which probably we might not be aware in the first time. But that is something which, whatever knowledge we have in our first and second year of college through the maths courses, it would be a little bit understanding, but we will
Okay.
have to put in more efforts in order to understand that in detail. But yeah, I wouldn't say it's a
Yeah.
difficult subject; it's a challenging subject. Like you should have to put your heart and soul into it in order to crack it out sometimes.
Okay.
Yeah.
So what are the other avenues that you generally prefer to refer, like to study on your own, apart from the lectures that happen to have in your college?
I would say there are quite a good number of materials available in internet, and
Hmm.
us being a COVID batch, almost we spent our 2 years in lockdown. So
Yeah.
we resembled most of the learning through online uh, portals as well. So there was initially it took a year almost to get accustomed to this online mode. Teachers were also finding it difficult. What would be the source through which we can share the learning into? So during the time, all the NPTEL courses which were there in YouTube or some other crash courses which were there in YouTube, those were really helpful, I would say. So at least for example, for control systems, there used to be one of the NPTEL courses in YouTube by an IITM professor. I'm not sure who is the name is, what's the name is, but that really helps in understanding the depths and detail. Each, I would say, there will be some 40 to 50 lectures of 1 hour each. So if you look and spend the time into it, you'll actually learn the amount of zeal present in it. So I would say the Google or the YouTube, whichever is the source, it has a humongous amount of data available. And one other thing would also I would say is that I've recently learned from my workspace in order to understand certain things is instrumentation.tools.com. That's a good website which would help in explaining the concepts in very much basic fundamentals. So say for instance, if what to understand what is a level transmitter, what is how does a differential pressure level transmitter works, you just Google it under or type it under instrumentation tools. It will help you in jotting down the basics of it. So that will be helping in understanding it in detail. And I would say probably you can take one random article in instrumentation tool every day and just learn it out so that it will be helpful for your competency development in instrumentation.
Yeah, nice. So, like, assume if someone approaches you and asks you for, like, during your 4 years, you might have planned something and, you have executed few and you might not have. Okay. If someone asks you for a right plan, like, what should be my yearly milestone that I should have in your 4 years of my course at ICE? What would be those such that I'll have multiple options to choose at end of my course that, according to my will and wish, I will choose my career path.
Uh, so I would say that your yearly milestone would again depend on which year are you in. So the first year, I would say it would just delving into projects and like other stuff. Like our college has multiple clubs in it.
Yep.
So you can probably choose which club is of your interest, and that will help in identifying whether you have interest towards instrumentation control or is something that you have a different interest. So I would say that point you should probably delve into the interest of yours rather than not sticking to instrumentation and control. And
Hmm.
say if that is the case, you can probably work on a RMI robotics club. So robotics clubs projects you can probably work even I mean, irrespective of whether we are selecting into it or not generally the inductions happen during the first year to second year transition periods. So in that time, the summer vacation can be utilized to learn something, a new software, say for instance, an Arduino software. That will be really helpful for our projects in the future because we don't have a specific course on Arduino microcontroller. I
Hmm.
think one of the disadvantage we have in our coursework is that even if courses like MPMC, microprocessor, microcontroller, we still learn the conventional 8051 and 8085. The courses have not yet been revamped. So that would be a good opportunity. The first year summer vacation would be a good opportunity to learn interest, whichever interest deals you. And if it is coding, you can probably try out that as
Yeah.
well. And then
Okay.
once you develop interest into it, you can go to that particular field. But towards instrumentation control, I would say work on projects like for RMI inductions or something of other sort, which would help you in learning the basics of what different softwares or different tools or different microcontrollers are available in market. So towards the second summer vacation, that would be another yearly accomplishment or milestone, I would say, wherein you can start looking onto internships or not an internship as in not through placement community or an external internship through a professor in college, rather through your influences or your people, your friends or family who have influences in certain fields. You can probably go and work there. Or there is a Siemens Center of Excellence in our college as well So in NIT Trichy. So those kind of avenues where you can have and learn something, that is something where you can go and understand. If you go to an industrial exposure, sure, it will help you in understanding not just the instrumentation part, but rather how an industry works, how things in industry work, how instrumentation is associated over there. So all of that can be understandable when you go to the second year. But third year internship, the third year part, the milestone would be more towards having an internship. So it can be either to my placement community. And trust me, in case of placements, we don't have much instrumentation companies opening up for internships. It would be rather analytical or software jobs which comes as placements. So if at all you want to develop an interest on a particular subject in core, I would say probably reach out to industries like ONGC, HPCL, or those kind of process industries where you can find out an internship. It can be either through your family friends or through
Mhm.
company portals which would tell the openings, or it can be a research internship as well, like doing under a professor, taking up a problem statement and working on it. I would say the second year and the third year milestones would be helping you in deducing your career, whether you want
Correct.
to pursue a master's or whether you want to go for a job. So that would probably help. And again, I would say that that is not the only research. Say if you're doing a research internship, you need to go to masters.
Master.
I did a research internship and I ended up
And
applying for
job.
a job.
Yeah.
So it is again, it all depends on the market dynamics. When we were there, we were in a COVID situation, lockdown, so we did not get any sort of internships. We had to rely on research internships only. So there will be other factors also involved into it. But based on that, you will have to frame yourself and frame, and all it depends on your interest. So you just have to streamline your interest and work towards it, I would say.
Yep, nice. So, out of the popular destinies after undergrad, like, as we already mentioned partially, like one is either government job or corporate job, that is first. Second, you go for higher studies, MS or MBA, or starting your own business. So, in case of starting own business is very rare these days after undergrad. So, in the first two options, like you said, like on basis of your own interest and the market dynamics, you will choose this. So, how did you choose that you want to go for job, or did you eliminate going to masters?
Well, I did not completely eliminate going to masters because learning is a never-ending process, right?
Correct.
So we would have to learn, like have that zeal towards learning. And trust me, if you settle yourself in a life after your 30s, you never
Mhm.
want to go and do a masters because there is multiple other factors. This is the
Correct.
only age where to masters, so I never definitely never closed the option. But again, as I said, the situations, the circumstances around
Mhm.
me would probably want me made me to choose to pursue a career in job. And to be very honest, Frank, the amount of core companies which open for us would be limited. So I just thought,
Mhm.
okay, probably ExxonMobil came up. Why not just try it out? Probably, if I get into it, it's good. If not, obviously my master's was my backup plan
Yeah.
kind of at that
Okay.
moment.
So
So
you prioritize job first and
lucky
then
enough or
yeah.
not,
Yeah.
yeah, so my case was like I prioritized job first because the market, like someone providing me job at that time during the COVID situation was like it felt like okay, at least that is a
Yeah.
value shot I would have because
Correct.
the masters dynamics in like the abroad they had multiple attritions, recessions, and all of
Correct.
that
True
going.
that.
So I did not want to risk my career over there going it because everything was uncertain. So I
Yeah.
thought okay, probably I will take a job now. And once if I even have of doing masters, that can be after 2 to 3 years of my company after my work experience. That would add an added advantage. And one thing which I want to tell you here is that people generally think that doing masters right after your bachelor
Correct.
degree is most like efficient or suitable. Trust me, even if you do masters after 2 to 3 years of work experience, that also adds to an added advantage because people would want that work experience because like a couple of my friends who went to masters right after their bachelors, they found it very difficult or challenging when people around them have good amount of work exposure and experience. They know how market works, how does the
Correct.
technology around them is. So that would be probably helpful if you even do a job and then go apply for a master's. And that's just a point which I would like to
Yep.
iterate over here.
Yeah, that's really good to have a perspective and give the way that you have planned your future. So, when you join any company after, like you said, ExxonMobil, so what is the role that you've been offered? Is it like graduate engineering training, or if it is that, what you'd be promoted to after a year or so?
So again, this would depend on the companies to company, at
Mhm.
least from my perspective in instrumentation control. So I was offered as an INC engineer in the first place.
Mhm.
Obviously, there'll be a little bit of probation period, but that
Correct.
doesn't affect my role here.
Yeah. Yeah.
And we work in a company where we don't have too much of role changes. It will be mostly
Mhm.
instrumentation and control engineer, whereas it will be more exposure towards I would work here. So I work here remotely in a TC in Bangalore. TC means Technology Center. So, but after a while, I would probably work in a refinery or a chemical plant where
Mm-hmm.
I would work as an instrumentation engineer. So my role would remain probably as an instrumentation control engineer. As my experience, I gain my experience, then is something where I would probably be going to a higher position or so. Either it can be in a technical role or in a managerial role, because ExxonMobil offers both techno managerial roles. So you
Yeah.
can choose your path in a managerial role wherein you can go for a leadership position, or you can go for a technical role wherein you can be a technical expertise in that particular field.
Yeah.
But if you go into companies in Indian companies or general companies, they offer a GEP
Mhm.
package. And once they initially 1 or 2 years would be in training period, and then you will be promoted as an engineer or whatever is the case.
Yeah. Agreed.
That's what I.
So, Santosh, apart from ExxonMobil, if you have to name few dream companies which are core ICE, what would be those?
Mm,
Like, if at all it is not a COVID year where every company is hiring, given that
mm,
as an
mm,
assumption. So, what are the top
mm.
5 or 6 dream companies that one should aim to be a part of?
Yep. So answering to that question, so I would again say that process industry is one of the good start place because it has a humongous amount of instrumentation and control involved.
Hmm.
So I would say companies like Exxon, Shell, those if they open up, and ours is mostly restricted towards India. So whatever
Yeah.
Exxon, Shell, Reliance, BPCL, HPCL, all of that would be a good resort. Or
Yep.
if there are companies like Honeywell, Yokogawa, ABB, all of those control system related companies or
Mhm.
instrumentation related companies, if what all they also, that's a good risk to probably start your career into. And also there are few other home automation systems or few other industries which might can hire. So again, you can
Mhm.
also use that as a resort to probably end up into. One
Mhm.
thing which I want to say is that the amount of package that core company offers versus the amount of package analytical company or a software company offers, it would be definitely in the lower side. The core would be
Mhm.
in the lower side. So if money is a factor for joining a particular industry for you, then core is not a good option because we would definitely not be having that much amount of pay. The only thing
Correct.
which would want you to join into a core company is the amount of zeal and passion which I mentioned earlier. That should be the
Mhm.
reason wherein you should not be the case that money shouldn't be a factor initially, I would say, to
Mhm.
join into a company. Obviously, if you're interested in software, then yeah, money could be a factor wherein which offers a higher package, I'll probably go and
Yeah.
give my shot there. But in case of core companies, that is not the case. Even people start with 3 to 4 LPA, 5 LPA. Those are very minimal. But still, it's a good amount to start to, and you can climb up your way, climb up the ladder your way up in order to get into a better position, I would say. So
Yeah.
in this case, at least ExxonMobil was one of the companies which had offered a good package when we joined. So I would
Mhm.
say ExxonMobil can be an option for people who can apply. And also there are other companies like which offers equal amount of package, Reliance and EPCL, HPCL, all of other companies as well. So you can definitely apply for those as
Yeah. That's a good point about like choosing the passion or the money on basis of the scenario. That's a great point. So, if at all, if you see as the future market outlook for IC engineers, what would be the sectors that they should focus? Because you have partially answered it, but if you have to be like, more elaborate about what are the areas that one should focus and what are the skill sets that they should add due to the, technology advancement these days. So what are the additional skills that they should enhance into their bag such that, they are up running in the market?
Uh, to answer this in the ExxonMobil perspective, like as in what skills required here. So one thing which I highlighted earlier is the DCS and the PLC communication. So that generally for us comes towards the seventh or eighth semester. So what happens is people generally might become complacent or relaxed once they get placed or they get into a job, right? So that should not be the case because those are the subjects which should be crucial for any industry, I would say. Because how do you measure all the signals, you measure everything, how do you collect it, how do you analyze it, how do you
Yeah.
understand it in detail? That all depends on my distributed control system and my process programmable logic controllers. So those are the courses which I would say it is not an additional extra skills, rather it is the definite amount of skill which you would want to have in order to not to be left out or not to be in a position where you don't possess that particular skill in a company, I would say. And apart from that, a little bit of industrial knowledge. Like I would say that is probably something which would not come through our coursework. rather understanding the dynamics of how your industry works. You should not be in a position where you don't know what is an ExxonMobil and you just apply it to it, right?
Yeah,
So you
agree.
should be probably doing a background check wherein understand what is the company doing and what it is like, what it is primary product, what is its primary
Yeah,
market. All of
agree.
that analysis probably you can do. But trust me, all of the companies would have a proper orientation program wherein they would walk you through the company culture, walking through what are the businesses they are involved in. But I would say that the pre-work or the homework can be utilized,
Mhm.
it can be useful in order to understand things in a more detailed manner once you join into the company.
Yep. Santosh, what would be your last advice or guidance to all the aspiring IC engineers in coming, up for the viewers?
I would say that like never lose hope or never lose trust towards the subject because, as I said, this is one of the very niche subject wherein people might think that okay, instrumentation control is something that might fade away as time progresses, but it is not. It would definitely have a huge impact in one way or the other. Yes, today it
Mhm.
might be that the process industries are gaining a lot towards instrumentation, at least for the last 20 to 30 years. But as time progresses, it would be the other industries who would take up this. So automation, robotics, all of that would be a huge amount of area where people would focus on and instrumentation control would play a role into it. That obviously that it would require skills which are not just instrumentation control, probably electronics, electrical, and mechanical, at least in case of robots. To understand
Mhm.
robots completely, you'll have to understand the degree of freedoms, the mechanical aspects of it. But however,
Yep.
I would say that instrumentation control will still be an integral part of it. It's just that how we align ourselves to it and how do we enhance our technological skills associated to it. So I would say that just not restrict ourselves to the coursework because the coursework is something which was developed 25 years or 20, 30 years ago, where keeping in mind all the other aspects. But now the technology has evolved. Sometimes our coursework wouldn't be revamped to the amount where we have need to include. So say for instance, still our courses would talk about sensors and transducers, all the
Yeah,
very basic things in detail, but those are not probably applicable in industry anymore.
correct. Yeah.
So I would say that that again comes in hand to hand, wherein we should revamp the course, but that is more of college oriented decision. But at least from our
Mhm.
side, what we can do is that we can understand what are the new technologies available. That's something you have Google all by
Yep.
yourself. You can just Google
Yes.
out, understand what are the new technologies available. That will probably help you in creating that interest and zeal towards the subject. And trust me, instrumentation and control, as I told earlier, it is a field where it seems niche, but it has a huge amount of application. And trust me, you wouldn't be a person who's wasting his or her career in instrumentation. It would be a slow process. Obviously, you will not go into greater heights, but as time progresses, as you become a technical expertise in that, you would be valued to a very great extent. I would
Yep. Thanks a lot for your valuable insights, Santosh. It was great having you here. Yep. Thanks a lot.
say. Yes, thank you.